10.2 Ellipses. You look at the definition, it says an ellipse is the set of all points in a plane, the sum of whose distances from two fixed points is constant. Each fixed point is a focus, and to pluralize that, that's foci, of the ellipse. So you can see no matter where you move around on that ellipse, this distance, this sum, the d1 plus d2, the d1 plus d2 is always going to be the same. So there's your definition. You add these two segments, d1 and d2, d1 plus d2 is always going to be the same. If you look a little bit more in depth into the numbers, you're going to see an equation that looks something like this: x squared over a squared plus y squared over b squared equals 1. All right. Now, they give it to you in a different form here, but I don't know that I would remember two different forms. Basically, what you need to remember is a is going to be the bigger number and b is smaller. A is going to be bigger than b. But what you look at is you look at the major axis. And in the first example, the major axis is on the x-axis, which just means that your ellipse is longer in the x direction. So this number a would be bigger in the x direction. The second time through, if you look at the second picture, the major axis is on the y-axis. That just means that your ellipse is longer on the y direction, so that that a number down there is bigger with the y number. So they talk about the foci, and in order to find the foci, we're going to use this equation: c squared equals a squared minus b squared. Example 1, graph each ellipse, find the coordinates of the foci, and give the domain and the range. So when you first see this, it does not look like the equation is supposed to look like. So there's a little bit of setup involved. If you go back and look here, we always want our formula to equal 1. It's going to be x squared over something plus y squared over something equals 1. And so in this problem, we see that it's 4x squared and 25y squared. We don't want those numbers, but we also don't want it to equal 100. So we're just going to basically divide everything by 100. And we're going to reduce those fractions. 4 over 100 reduces to 1 over 25. So we would see x squared over 25 and y squared. You reduce that fraction. 25 over 100 is 1/4, and 100 over 100 is 1. Okay, so now we've got our form. This is exactly the form that we want. Okay, so when you see that 25 number is bigger than the 4 number, we can see that this ellipse is going to be stretched in the x direction. Okay, now according to our formula, a squared equals 25. And so we should be able to tell that the a number equals 5, because 5 squared would be 25, and the b number would equal 2, because 2 squared would equal 4. Okay, so the longer one, the bigger side, that's the major axis. So we can see that the major axis is in the x direction, and the minor axis is in the y direction. So we can graph this. And we'll do it fairly quickly. One, two, three, four, 5. 1, 2, 3, 4, 5. That's going to be your major axis, and basically a equals 5 means we go over 5 from the center, and this is centered at 0, 0. Think about your center of your circle. The x squared would be like x minus 0, and so your center is at 0, 0. And then for your minor axis, we need to go up 1, 2, or down 1, 2. And we've got points right there. So our ellipse looks something like that. And now we need to find the foci. Okay, so the foci, I gave you that formula. C squared equals a squared minus b squared, so don't get that confused with your Pythagorean theorem. C squared equals a squared minus b squared. Well, a squared, a was 5, so a squared was 25. And b was 2, so b squared was 4. We've got 25 minus 4 is 21, so c squared equals 21. You solve that equation, you're going to get plus or minus square root of 21. Really, we can just be concerned with the distance, so the positive value is just that 21. That's square root of 21. Use a calculator to see that the square root of 21 is about 4.6 or so. And so if you had to graph the foci, you would start at the center, which in this case is 0, 0, and go along the major axis about 4.6 in either direction. Okay, so square root of 21 is about 4.6. So in order to name the foci, we need to name those coordinates. So this coordinate right here, this focus right here, is going to be negative square root of 21, comma 0. And then this one over here is going to be positive square root of 21, comma 0. As for the domain and the range, remember domain is the x numbers, so imagine squashing it on the x-axis. That's going to go from negative 5 inclusive to positive 5. And then your range, your y numbers, looks like that goes from negative 2 to positive 2. Okay, so now we're going to do part B. I'll try and make this a little bit quicker. See how it equals 441? We don't want that. So we would divide by 441 to make it equal 1. So reducing your fraction, 49 over 441, is going to reduce to 1/9. So we have x squared over 9, and 9 over 441, that reduces to y squared over 49 equals 1. So that's kind of our general form that we like. We can see an ellipse that has a center at 0, 0. You should be able to see the a number now is along the y-axis. There's your major axis is along the y, and your minor axis is along the x. So then we would have vertices at 7 up from the center and 7 down from the center, as well as 3 to the right and to the left of the center. Okay, so now we need to find the foci. So that's your c squared equals a squared minus b squared. That's always what it is. So that's going to be a squared is 49 minus b squared is 9. That's 40. So you have c squared equals 40. C is going to equal square root of 40 is the distance. And so that's going to be 6 point something. That's going to be right in here somewhere. And down here somewhere. 6.3, 6.4, I think. Okay. So if you reduce that, square root of 40 is 4 times 10. That's going to be 2 times the square root of 10. So your foci would be at the points 0, comma 2 square root of 10 and 0, comma negative 2 square root of 10. That would be here and here. Those are your foci. Okay, lastly we need domain and range. So again, domain is the x numbers. Looks like that goes from negative 3 to 3. And your range, your y numbers go from negative 7 to positive 7. Example 2, write the equation of the ellipse having center at the origin, foci at negative 5, 0, and 5, 0, and major axis with length 18 units. What I would do is try to draw a quick diagram. So they give you the foci at 5, 0, and negative 5, 0. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We've got foci right there. Okay. That also tells you that it's going to be going in the x direction. It's longer in the x direction than the y direction. So when they say that the major axis has length of 18 units, we'll cut that in half, and that's going to be this length right here, 9. And so I can tell that that's going to be the point 90, and that would be 9 as well. So that's going to be the point -90. Okay, so we have to write that equation, I guess. Well, we have the c value is 5, that distance is 5, and the a value is 9. Remember that formula for focus, c squared equals a squared minus b squared. Okay, so the a value is this 9 right here. That's the major axis, that's the bigger number, so you're going to have 9 squared is 81. But your c value is 5. That's the focus number. So 5 squared equals 9 squared minus b squared. They didn't give us any information about the y direction of the minor axis. So we just solved this equation. 25 equals 81 minus b squared. Let's rearrange this. B squared equals 81 minus 25. 81 minus 25 is 56. So then that distance, take the square root, that distance is square root of 56, or 2 times the square root of 14, or approximately 7.5. Okay, now I didn't really need that distance. That's going to be the point 0, 7.5, and that's going to be the point 0, -7.5, roughly. But what I need, I guess, for my equation is the b squared value. Remember, your formula says x squared over a squared. A was 9, so square it. Not equals. Plus y squared over b squared. Well, b squared is 56, equals 1. And that's it. There's your equation. So you had to use that equation, c squared equals a squared minus b squared, to find your missing pieces, and then you've got it. Example 3, graph this function and give the domain and range. Now, if you look at it, it looks kind of crazy, and so you may not know what this looks like firsthand, but we don't like that square root. So what we're going to do is we're going to square both sides. If you square both sides, you're going to have y squared over 9 equals 1 minus x squared over 4. The negative sign goes away, the square root goes away, and so we get this, and you may recognize this is going to look like an ellipse. Okay, so add this x squared over 4 over, and I see x squared over 4 plus y squared over 9 equals 1. So if you imagine graphing this, okay, you graph this, and the a number is the bigger number. That's going to be the square root of 9, which is 3, and the b number is going to be 2. So it's longer in the y direction, so keep that in mind as you plan this out. 1, 2, 3, 1, 2, 3, and in the x direction, 1, 2, 1, 2. Okay, now you're tempted to draw an ellipse, but actually what happens is we don't have the ellipse, okay? We don't have that ellipse because of that negative sign that was in the beginning, okay, the negative and the square root part. If you look at y over 3 is equal to negative something, okay? And so, in other words, y over 3 is less than or equal to 0. So it's negative, all right? Solve for y, multiply both sides by 3 or whatever, you're going to get y is less than 0, which means that we're talking about a negative, okay? Y has to be negative. So if you imagine your ellipse was going to go through these 2 points and these 2 points. Your ellipse was going to go through there, but we're only going to have the bottom half of this. This is only going to be the bottom half of our ellipse because we want the part where y is negative. So imagine where your y numbers are negative. That's it. We graphed it. Okay, it's the bottom half of an ellipse. So then the last thing, give the domain and the range. We've done this enough that you should know the domain's the x numbers. We're going from -2 to +2, inclusive. And then the range is the y numbers. And so that's going from -3 to 0. Now they give us the equation for an ellipse that's centered not at the origin, but this just should remind you of when we had a circle that wasn't centered at the origin. You've got that x minus h and that y minus k language. You should still notice that the A is the bigger one and B is the smaller one. So in this case, when A is the bigger one, the ellipse is stretched more in the horizontal direction. And of course the other way, if A is on the y, then it's stretched in the vertical direction. Example 4 says graph that, give the domain and the range. Well, it should be obvious to you that the center is at the point x is 3 and y is 0. So you've got that 3, 0. Let's go ahead and graph that. 3, 0 is the center, but also you can look at your equation and see that square root of 36 is 6 and square root of 9 is 3. So you've got your lengths or your distances away from that center of 6 and 3. So since that 6 is going with the x, that's giving you the x-axis is your major axis. So I'm going 6 in the x direction, 1, 2, 3, 4, 5, 6 in either direction. 1, 2, 3, 4, 5, 6. That's going to be my major axis. Notice 6 plus 6 is 12, so your major axis would be 12 units long. And your minor axis go from the center 3 up and 3 down. So I see an ellipse looks like that. Okay, so graph it. Give the domain and the range. That should be fairly simple. Domain is the x numbers from -3 to +9. The range is the y numbers. That's from -3 on the y to +3 on the y. Eccentricity of an ellipse is the measure of its roundness. It's given by a formula, E equals C over A, and the C and the A numbers are the same ones that we've been using in the other examples. Now, they're both going to be the positive, the distant. We're talking about the distances, so it would be the positive numbers. It would always be a positive number. Example 5, find the eccentricity of each ellipse. X squared over 81 plus y squared over 100 equals 1. So you can see the A number is with the y. It's going to be square root of 100 is 10, and the B number is going to be 9. So before we can use that new formula, we're going to have to find C from the old formula. C squared equals A squared minus B squared. So that's going to be 100 minus 81 is 19. So C squared equals 19. C is going to equal the square root of 19. Okay, square root of 19. So now we can use our formula, our new formula. E equals the C value over the A value, square root of 19 over 10. Which is about 0.44 or so. So then we do the next one, and it's really the exact same thing. You can see that A is going to be the square root of 11, and B is going to be the square root of 6. So we need to find C. Well, that's just going to be 11 minus 6, which is 5. So C squared equals 5, square root of 5. C is the square root of 5. So we find the eccentricity is going to equal that value over the A value, square root of 5 over, well, it's not 11, it's the square root of 11, because E equals C over A. E equals C over A, and the A is that square root value. So let's go square root of 5 over square root of 11. Find about 0.67. He's about 0.67. Now, one thing to notice about eccentricity is the closer to 0 you get, the more round it is. So if you had an eccentricity of 0, it would be a circle.